Hello everyone, this is Prashanth, Minister of Aeronautical Engineering, Hyderabad. Up to the last session, we have discussed about IoT enabling technologies. That is, totally we have 5 types of IoT enabling technologies as per our syllabus. So in that first 2 is wireless sensor network, second one is cloud computing, the remaining 3 is big data analytics, communication protocols and embedded system. So the first, in the last session, the first 2 is wireless sensor network and cloud computing. In the wireless sensor network, we have discussed different types of requirements to develop wireless sensor network. What are the requirements, what are the precautions, what are the challenges we are discussed about wireless sensor network. So in the cloud computing, we have different service models in the cloud computing. That is, basically we have 2 types of models in the cloud computing. That is deployment models and service models. So in the deployment models, we have public cloud, service cloud, public cloud, private cloud, hybrid cloud, like that. We have 4 types of the deployment models in the cloud computing. As same as in the service models, we have 3 types of service models in the cloud computing. That is infrastructure as a service, platform as a service, infrastructure as a service, platform as a service, software as a service. So these are the 3 types of service models provided by cloud computing. In order to provide that, we have different companies like Reliance Communication, Amazon Web Service, Amazon Cloud Computing. So these are the things we discussed in the last session. So that is wireless sensor networks and cloud computing. So these are the 2 IoT enabling technologies we discussed up to the last session. So now we move on to the another 3 types of IoT enabling technologies, that is big data analytics along with communication protocols and embedded system. So let's move on to the first one, big data analytics. So what is big data analytics? What are the requirements of big data analytics? Along with that, we have so many advantages, and along with that we have disadvantages also. So here, what is big data analytics refers that methods, tools and application used to collect, process and derive insight from the varied high volume, high velocity data sets. So basically the basic definition for big data analytics means what? It is a methods and tools and some combination of some applications that is used to collect first you can collect the data, then process the data and apply onto the IoT devices. So this is about the first, what is big data analytics. Next, this data sets may come from variety of sources such as web, internet, mobile, email or social media and networked smart devices. So this is the first, we have to define what is big data analytics. So it refers to methods and tools and application used to collect, process and derive insight from the varied high volume or high velocity of data. So this data can come may across from different sources like web, mobile, email, social media and network smart devices. So this is about the first 2 points regarding big data analytics. Next, this is often future data that is generated at a high speed and varied in form of ranging from structured to semi-structured to unstructured data. That is either it is image files or audio files or symbols or any other data that can some amount of data in terms of different categories. So for example, big data is generated by IoT systems are census data generated by IoT systems such as weather monitoring system. Weather monitoring stations are system. Next is data generated by IoT systems for location and vehicles. It depends on particular location. Either maybe it is networked or unnetworked location. The data can collect from the IoT devices. Next, what are the vehicles? Either it is a constant speed vehicle or moving vehicle or a moving fast vehicle, whatever it may be, that can some amount of data it can collect. Next, data generated by retail inventory monitoring system. So we have some retail websites are like Amazon or Flipkart, like that. We have some retail websites. So from that only we have to generate or collect some data. So this is about the basic points of big data analytics. What is big data analytics? What are the applications of big data analytics? Next, move on to the some benefits and advantages of big data analytics here. So the first one is risk management. So in that, what is the use case of big data risk management? So Banco de Oro, a Philippine banking company, use big data analytics to identify fraudulent activities and disappearance. So this is one of the real-time applications of big data analytics. Next, the organizations leverages it to narrow down a list of suspects or root causes of problems. Next, product development and innovations. The first one is management. The use case is nothing but one of the company in Philippines. It used big data analytics to identify the fraudulence. Next, product development and innovations. What is the use case? Rolls-Royce, one of the largest manufacturer of jet engines for airlines and armed forces across the globe, use big data analytics to analyze how efficient the engine are designed, or if there is any need for improvements. So this is the use case of product development and innovations. The best example for that is Rolls-Royce company. It is we already know, one of the largest manufacturer company to prepare jet engines for airlines. So these are the two main advantages of big data analytics: risk management along with product development and innovations. Next, another benefits of big data analytics here, quicker and better decision making within organizations. Quicker and better decision making within a fraction of seconds, the decision taken by the user. So Starbucks use big data analytics to make strategic decisions. For example, the company leverages to decide if a particular location would be suitable for a new outlet or not. They will analyze several different factors such as population, demographics, accessibility of the location, and more. This is the example for quicker and better decision making within organization only. So not applicable for outside of the company. So this is only within the organization only. So the next one, improve customer experience. What is the use case for improve customer experience? Delta Airlines use big data analytics to improve the customer experience. They monitor tweets to find out their customers' experience regarding their journeys, delays, and so on. So, for example, if you want to, if you purchase one book from the Amazon, so after delivering the product, they can send the message to give the feedback. Just rate your experience in terms of 3 to 5 questions. What is the which type of experience you have on the product? Whether the delivery boy is use fluent language to speak with us, like that, they can take the feedback from the customers. So this is one type of advantage of big data analytics: improve customer experience and quicker and better decision making within the organizations. Next, what are the characteristics of big data? So here we have 3 types of characteristics of big data here: volume, velocity, and variety. How much volume it having? Which type of velocity? How much velocity? It provides the time at which the data is collected and analyzed. In the volume, we have in terms of terabytes, it provides the amount of data and the form of data. The velocity, it provides the time at which the data is collected and analyzed. Variety provides the which type of data it can collect it. Volume, velocity, and data variety. So volume, through the no fixed threshold for the volume of data to be considered as big data. However, typically the term big data is used for massive scale data that is difficult to store, manage, and process using the traditional databases and data processing architecture. The volume of data is generated by modern IT, industrial and healthcare system. So this is the first type of characteristics of IoT, big data analytics. Next one, velocity. Velocity is another important characteristic of big data. The primary reason for exponential growth of data. Exponential growth of data. Velocity of data refers how fast the data is generated and how frequently it varies from high value to low value or low value to high value. It can vary the data, depends upon our requirement. Next, variety of data. Variety of data refers that form of data becomes different forms of structured or unstructured data, including text data, image or audio, video and sensor data. Either whether it is maybe structured, whether it is maybe unstructured data, whether it is structured or unstructured, the data in terms of text data or image, audio or video and sensor data. So these are the three characteristics of big data: volume, velocity and variety. So next, move on to the different types of big data analytics, that is descriptive analysis. Here we have two descriptive analysis. In the descriptive analysis, this summarizes the past data into the form of that people can easily read. This helps creating reports like a company's revenue, profit, sales and so on. Also it helps to in the tabulation of social media metrics also. Here we have the first descriptive analysis here. What is the use case of descriptive analysis? Though chemical company analyzed in its past data to increase facility utilization across its office and lab space. Using descriptive analytics, the company was able to identify undestructured space. This space consolidated helped the company severely save nearly $4 US. So this is the use case of descriptive analytics. So here we have descriptive analytics, diagnostic analytics, predictive analytics and prospective analytics. So here we have four types of big data analytics. The first one is descriptive analytics. What is the use case of descriptive analytics? Though chemical company, the second one is diagnostic analytics, predictive analytics and prescriptive analytics. So let's move on to the second types of big data analytics, that is diagnostic analytics. The name itself, diagnostic, means what? So this is done to understand what caused a problem in the first place. Technical drill down, data mining and data recovery of all the examples here. Organizations use diagnostic analytics because they can provide in-depth insight into the particular problem. So in order to study the problem in depth, we use diagnostic analytics. What is the use case of diagnostic analytics? An e-commerce company reports show that their name sales have gone down, although customers are adding product to their carts. So this is the use case of diagnostic analytics. This can be due to various reasons, like the form did not load correctly, or shipping fee is too high, or there are not enough payments option are available. So this is about diagnostics analytics. This is the second type of big data analytics. The next one, predictive analytics. This is type of analytics tool into the historical and present data to make predictions of the future. Depending upon the past data, the future data can be estimated. So the predictive analytics uses data mining, AI, data mining, artificial intelligence, machine learning to analyze the current data and make predictions about the future. It works on the predicting customer trends, market trends and so on. What is the use case of predictive analytics? PayPal determines what kind of precautions they have to take protect their clients against fraudulent transactions. PayPal is one of the online platform of payments. So that is determined what kind of precautions. So when you make some transaction through the PayPal, so we have followed different precautions. So using predictive analytics, the company uses all the historical payment data and user behavior data to build an algorithm that predicts fraudulent activities. So this is about predictive analytics. First, we have to by using past data, we can estimate or we can predict the future data. The use case for predictive analytics is PayPal. The last one is prescriptive analytics. This is the fourth type of big data analytics. So this type of analytics prescribe the solution to a particular problem. Prescriptive analytics works with both descriptive and predictive analytics. It is also known as it is the combination of both descriptive and predictive analytics. The features which are available in the descriptive and predictive analytics, the same feature also here, features also will applicable for prescriptive analytics. But we have some little bit changes are available. So the use case for prescriptive analytics can be used to maximize an airline's profit. This type of analytics is used to build an algorithm that will automatically adjust to the flight fares based on numerous factors, including customer demand, weather report, destination path, holiday seasons, and oil prices. So this is the fourth types of big data analytics, that is prescriptive analytics. It is the combination of both descriptive and predictive analytics. So next, move on to what are the big data analytic tools here. So here we have some types of big data analytic tools. The first one is Hadoop helps in storing and analyzing data. The first tool in the big data analytics, Hadoop helps in storing data, analyzing data. Next, MongoDB. MongoDB used to data sets that change frequently. Next one, Talent, used for data integration and management. Next, Cassandra, a distributed database used to handle chunks of data. Next, Kafka, a distributed streaming platform that is used for fault-tolerant storage. Next, Spark, used for real-time processing and analyzing large amounts of data. The last one, Storm, an open source real-time computational system. So these are some big data analytics to build a real-time example within the different companies. Hadoop, MongoDB, Talent, Cassandra, Kafka, Spark, and Storm. Next, big data industry, some applications having in terms of commerce, marketing, education, and healthcare. So in terms of commerce, predicting customers trends and optimizing prices are few of the ways e-commerce uses big data analytics. So this is one of the application of big data in e-commerce. Next, marketing. It helps to drive high ROI marketing companies, which result in the improved sales. In order to improve the sales, it can use big data analytics as per the requirement. The next one, education. In education, used to develop new and improve existing courses based on the market requirements. So for example, Education Policy 2022 will apply based on the requirement. Next one, healthcare. Within the help of patient's medical history, big data analytics used to predict how likely they are used to have health issues. So these are the four types of industry applications of big data: e-commerce, marketing, education, and healthcare. So these four types of applications can cover all the things, I think: commerce, marketing, education, and healthcare. Next, remaining applications here: media and entertainment, banking, telecommunications, and government. So in media and entertainment is used to understand the demand of shows, movies, songs, and moreover to deliver a personalized recommendation list to its user. For example, we have different OTT platforms nowadays. We have like Amazon Prime, Netflix, Hotstar, Disney, like that we have. So in every company using big data analytics as to understand the customer requirements, either Netflix, Amazon Prime, or Hotstar, whatever it may be. Compulsory the OTT platforms using big data analytics to understand the mentality of or mindset of customers. Next, banking. In banking customer income and spending pattern to help predict the likelihood of choosing various banking offers like loans, credit cards we have. So here, for example, SBI Yono app like that. So in the Yono app, you only need one. Within the single app only, we have different types of applications like accounts, credit loans, credit cards, personal banking, car insurance, bike insurance. Like that, we have in one application only, we have different types of applications. So that is by using of big data analytics. So this is the best example for real-time SBI Yono application. Next, telecommunication. It is used to forecast network capacity and improve customer experience. Forecast the bandwidth value or capacity value of the networks. Next, government. Big data analytics helps governments in law enforcement among other things. So these are the remaining four of applications of big data: media and entertainment, banking, telecommunications, and government. So next, IoT enabling technologies, wireless sensor network, cloud computing. Next, big data analytics. So the fourth one is communication protocols. So what is communication means what? So in order to transfer the data from one place to another place or source to destination, we have to transfer some information as per our requirement. So the process is nothing but communication. So here, what is the definition of protocols? We have different types of protocols in order to send the data, like Z-Wave, Bluetooth LE, Google Thread, Wirepass Mesh, NB IoT, LoRaWAN, Sigfox, Z-Wave. So what is the definition? These protocols define the data exchange formats, data encoding, addressing schemes for devices, and routing packets for different source of destinations. The other function of the protocols include sequence control. While the sending the data, it can follow the sequence, flow control, and retransmission of last packets. So while the transmission, in the middle of transmission, some of the packets may lose due to the propagation losses. So in order to identify that, we have different methods in the communications. So communication protocols allows device to exchange data over the network. So this is about communication protocols here. So the IoT communication protocols, viable communication protocols that can be interchanged to the Internet of Things, that is concept 4. Z-Wave, Bluetooth, long-term evolution, Google Thread, Wirepass Mesh, NB IoT, WAN, Sigfox, like that. So in our subject IoT, we have some communication protocols like these are. So these are the technologies used communication protocols in order to send the data. Next, big data analytics, communication protocols. The last one is embedded system. So basically the embedded system defined, it is the combination of software, hardware, and mechanism. By using software, we can build hardware device, hardware kit with some mechanism. So this is the basic definition of embedded system. So in the embedded system also, we can implement the IoT. For example, definition: the embedded system is a computer that has a computer hardware and software embedded to perform specific task with a mechanism. This is the basic definition of embedded system. So what are the key components of embedded systems? Microcontroller and microprocessor. Memory, either read-only memory or random access memory or cache memory, flash memory, whatever it may be. We have some memory devices. Networking units, either single point or multi-point or double point, like that. Next, input-output units. Compulsory we have to give some input. Exactly, we have to take some output from the output port. Next, storage, whether it is kilobytes or megabytes or terahertz, like that we have some storage devices. So this is the basic definition of ideal structure of embedded device. User interface, input, we have to give input, take the output, link to other systems. So this is the basic definition of embedded system. These are the key components of microcontroller, microprocessor, memory, the RAM or cache memory, networking units, input, output, and storage. So next, embedded devices. So embedded devices are the objects that are built the unique computing systems. These systems may or may connect to the internet. So if you connect to the internet, then it can be converted into smart device, that is IoT device. An embedded device system generally runs as a single application. However, these devices can connect through the internet and able to communicate through other network devices. So the device is able to communicate through the other network device by using internet. So this is other device. So the first, basically this is the embedded system device by using some communication protocols, Wi-Fi, Bluetooth, Ethernet, Zigbee, ISDL protocols. So by using this protocol, we can connect to the local network. So the local networks are LAN, MAN, NET, MANET, like that. So by using this internet, so through the internet we can connect to the other devices. So these are the peripheral hardware devices like sensors, actuators, and drivers. So this is the complete overview of embedded device. The devices are either sensors, actuators, or drivers. That is, can communicate through the communication protocols like Wi-Fi, Bluetooth, Ethernet, Zigbee, ISDL. So that is connect to the local network, that is LAN, MAN, MANET. So that is connect to the internet. Through the internet, it can connect to the other device. So this is the complete overview of IoT embedded device. Next, hardware, embedded system hardware. The embedded system can be type of microcontroller or microprocessor. Both of these types of contain integrated circuit, IC. So the essential component of embedded system is RISC family microcontroller like Motorola 68HC11, PIC 16F84, Atmel 8051, and many more. The most important factor that differentiate these microcontrollers within the microprocessor like 8085, their internal read and writable memory. Either it is maybe microcontroller, either it may be microprocessor, having different structures. So the diagram is like that. Peripheral hardware device, communication protocols by using local network, that can be internet, connected to the other device. Next, the embedded system that use devices for operating system is based on the language platform, mainly where the real-time operation would be performed, manufacture, build embedded software in electronics. Example: cars, telephones, modem, appliance, etc. It can be also complicated software for missiles, process control systems, and airplanes. So this is the last IoT enabling technologies, embedded system. So we have the first one, IoT enabling technologies. The first one is wireless sensor network. Second one is cloud computing. Third one is big data analytics. The fourth one is communication protocols. Fifth one is embedded system. So these are the 5 in wireless sensor network. We have what are the requirements requirements to develop the wireless sensor network among the associated devices. Next, cloud computing. In the cloud computing, we have different types of models, either deployment models and service models. We learn. Next, big data analytics. What are the types of big data analytics? What are the use cases? What are the real-time applications of big data analytics? We discussed in this session. Next, communication protocols. Which type of communication protocols we use different companies and to share the information through the other devices. Next, in embedded system. So in embedded system, we also use some hardware part can communicate to the other device with the help of communication protocols and local area networks. So these are the IoT enabling technologies, like that. So these are the references I used for this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.